Fine.
We are presenting today on the industrial grade heat gun and its properties. It's also known as Hello Kitty blow dryer.
It's a professional.
Yeah.
As you can tell by the label placed on it right here.
This is almost kind of a little bit messy. We kind of have the, front end, the back end.
The cone, the fan, and the coil assembly. Actually, I can't disassemble because I don't have a solder right now. This thing.
The grill, the spring earlier. The spring's over there by the sim, as well as the cooler. So, some of the features this heat gun has is that it can dry hair. It has a cool button. It has 2 speeds, high and low, and blows more hot air than Donald Trump. And
so it operates by rotating this fan to blow air over the heating elements, which will evaporate water on a person's head or shrink tubing.
so the first part we did was the cool button. You'll see it in the next one. And what it does is it makes it cool, so you just deal with it.
Yeah. It turns off the heating elements.
Yeah. It doesn't have any electrical conduction, no magnetic force, as it's made of plastic. And it does get scratched by a nail. Has about 0.9 grams weight, about a milliliter in volume, making the density, again, 0.9 grams per milliliter. And surface area about 2.285 inches squared, and it's very hard to bend, so it doesn't leave any deformations at all. And so this is the inventor part. As you can kind of see, it's about what it's supposed to look like. I think it's still sitting on the desk over there. No, it's in the butt. It's in there.
Yeah, it's actually inside.
We stuck it back in.
Yeah.
You kind of see it's just a small plastic piece, but it's cool.
The little tabs keep it in.
Yeah. See right there, there's one and one on the other side. Keeps it in. This is the multi-view sketch. You kind of see there's a lot of hollowing out of it. Just kind of make it so it can actually fit in it, because as you can see, that's not necessarily something where you can just like fit in. It has to be hollowed out to allow for some of the other parts to come in.
The grill is it's there to keep people from sticking their hands inside. It is conductive. It's magnetic. You can scratch it. Its mass is 0.20 pounds. It's 5.247 inches squared surface area. That's 0.069 inches cubed volume, and you can bend it.
And it also is good for cooking steaks. We've used it in barbecues many times.
And there it is in the inventor. And I forgot to hide my work planes. So there's my mirror plane. Yeah, here's the sketch. You can see. You can see how it's curved at the end, so that it fits inside the shell.
Some of the other parts we had was the fan, as you can see in the back, and it accelerates air over the heating elements and creating an array of DOAs that turn the AC current into DC, which is a full-bridge rectifier.
Yeah, we have a circuit diagram where we can show you how everything goes together. The heating elements, they're intended to get warm, and that's it. They just get hot.
Yeah. Super hot, super hot, super hot.
Alright, the switch turns it on. Yeah, there's a plastic cover. Here's the actual switch. The shell, again, it's another device to keep people from sticking their hands inside.
Well, when you have the grill on, otherwise.
Yeah. So this one's slightly more necessary because you can actually get shocked or electrocuted since your hands are probably wet after stepping out of the shower. And I'm sure there's probably some product safety things that most people are ignoring. Switch. So let's speed of the fan.
Yeah.
We may have put the switch on here twice.
Yeah. I just the cardboard cone, it's that thing right there.
Yep, it's a specially treated piece of cardboard that it goes over the heating elements and the flow of air is controlled.
So that's how it kind of goes together, and this piece can come on the back.
Did you know what it was especially treated with?
It did not say exactly.
Yeah.
We want to find that specifically.
So it basically doesn't burn it.
Yeah.
Yeah.
Oh, we went too far.
Yeah. Some of the sketches for the push. You got the grill up there. You got the cool button. You kind of got the cardboard cone, a spring that got disappeared, and then you got this little thing that goes with the spring that will keep the cool button out when it's not being pushed, and when it is being pushed, it will coil the spring and push this back so that when it uncoils, it'll go back and push it.
So here's a circuit. It begins with the switch over here, and on the high speed, there's no resistor. But if you're on the low setting, there is a 138.4 kilo ohm resistor, and so you go over here. Since it can be AC current, that means that it can switch between being positive and negative 60 times every second. So it has this array of diodes to make sure the DC motor can operate. So positive comes out there, negative comes out there, goes in, it hits the motor, which goes pretty fast since it's 120 volts. The heating element is 10.7 ohms, but it can obviously get really hot since you're putting a lot of wattage to it. Yeah, that's the cool button, which is a normally closed switch.
So the manufacturing process of this part, first off, it starts importing the motors and fans. This is common with a lot of other industrial grade heat guns. They were arrived pre-assembled to make it quicker because they're made from different companies. What they then do is they get coiled nichrome, which is specially used because it does not rust at high temperatures like other metals do. And so it kind of coils around a heating board that allows it to keep it kind of more compressed as opposed to much longer, because it's about a foot long of this stuff. So it's wrapped around to keep it within like 3-4 inches. And that just make it more compact and able to heat it better. And this is kind of a similar way to do when they're heating toast, because it heats the wires and then it will then heat the air or the bread or the fire. No, not fire. In order to make the plastic pieces, they use a technique called injection molding, which is when they inject molten plastic into stainless steel to kind of get the mold and the shape, and that makes the plastic components as well as the buttons and switches. Then they kind of put the components in place to kind of, this certain components usually within the circuitry that would prevent any overheating or electrocution, that would sort of like turn it off for it to be used, but it's still best to avoid not sticking in water because that seems to cause electricity to spark, and people sometimes tend to die. You have to be believing and figure out how to not die from electricity yet. Then they, within the pieces, they put in the component elements that allow it to heat and cool, as well as like turning the fan and all that. So a lot of electrical stuff, kind of keep it so that it works and works well. Then they would fasten and tighten the screws. As you can see, it was very tight. We had to basically rip the screws out with a cold dead hand.
Yeah.
Yes.
Yeah, I used the wrong side of the screwdriver initially and ended up stripping off the screws, so I had to drill it out.
Yeah, as you can see, this thing came screwed back in. And finally, what it will do is it will attach warning labels on the electric cords to the gun to kind of tell people what not to do, like set it on fire. That's bad. As well as like attach all final electrical components so that can be plugged in and used and not constantly going. So it's pulling from electrical circuits in your house as opposed to a battery, which would not really be safe for use.
The cardboard is specially treated to be more heat resistant, so it might not be as recyclable as normal cardboard. The plastic should be recyclable. We weren't able to figure out what kind of plastic this is. I assume it's probably ABS, but yeah, you should be able to recycle that. The copper in the wires can be recycled, just not by throwing it in, but you probably would have to take it to a recycling center. The switches and diodes could be reused in other projects if you wanted to.
And that's it.
Yep.
That's an industrial grade heat gun.
Good job. Whose Hello Kitty heat gun was that? Bobby's?
This was
That's what I thought.
mine.
That was yours?
Yeah.
Okay.
It's okay. There's another one. There's another heat gun at my house.
Another Hello Kitty one?
Yeah.
Okay.
Which was actually a replacement for this. It's getting old, but it still works. Well, it doesn't anymore.
Awesome.
It's a good part.